Okay, we're still waiting on some to come in. Looks like Hurley and others, but let's go ahead and get started. We'll take a look at these first couple equations here. The top one there, circled in blue, or surrounded in blue, is already in what we call slope-intercept form. And all that means is it's in that form, as we see here, that's y equals. And when it's in that form, we can read the y-intercept and the slope right out of it, as we did last week. Oh, here's more coming in. I'm going to pause for a second, let everybody get settled in. Okay, we've got more of you settled in. So let's go ahead and we'll keep going here. So that's that slope-intercept form. And when it's in that form, we can read the slope and the y-intercept right out of the equation. Of course, the first thing is that y-intercept. That's the number that is added or subtracted. In this case, it's minus 5. So we would start at negative 5 on the y-axis. That's what's called a y-intercept. It intercepts or intersects the y-axis at negative 5. And then we looked at the slope. And if you recall, the slope is the number that multiplies the x. That's this one. And slope is always of the form rise over run. So that's telling us that from this starting point here, from the y-intercept, we rise 1 and we run 2, giving us a second point. Now, since those are close together, I'm going to keep going. I'm going to rise 1 again, run 2, and let's go one more time just for good measure. Rise 1, run 2. So my line goes through those points. And I can even go back this way, going the opposite. I'm a positive 1/2 slope. I can actually do that as a negative 1 over negative 2. So instead of going up 1 over 2, I can go down 1 and go back 2 if I want to do points in the other direction. Because we know that line goes on forever in both directions off the sides of that graph. The second one here is not in that slope-intercept form. It's not of the form y equals. This is often referred to as standard form. Now, technically, standard form would actually have the whole number on the left side as well. Standard form would technically be 2x plus 3y minus 6 equals 0. Standard form usually isn't equal 0, but this is often, the way this one is written here, is often considered to be a variation of standard form as well. So looking at that, first thing we have to do to graph it is to put it into this slope-intercept form, y equals form. So I'm going to go ahead and I'm going to solve it for that variable y. To do that, I have to get rid of everything else that's on that side of the equation. So here's my equal sign. So I'm looking at everything over here. And just like when we solved for x in our other equations, we look at what is keeping y from being by itself. Well, here y has been multiplied by 3, and then the 2x has been added to it. And just like with our other equations, when we take it apart, we have to reverse that order. So we will subtract the 2x first. And again, remember from last week, we talked about when we are adding or subtracting from an equation, we only have to add or subtract to one digit on each side of the equation. So here we subtract 2x from 2x to leave us with 0. So all that's left is the 3y on that left side. On the right side, we subtract 2x, but we cannot subtract 2x from 6 because they have different names. This is 6 1s, and this is minus 2x's. So we just leave them as separate digits, 6 minus 2x. Then the last thing we have to do is we have to divide by the 3. And you recall from last week, we discussed that when we multiply or divide an equation, we have to multiply or divide every digit on each side. So here 3y is a digit. We divide by 3, cancels out the 3, leaving us with y. On the right side, we have two digits. We have the 6 and we have the negative 2x. So we're going to do 6 divided by 3 is 2. Negative 2x divided by 3. So negative divided by positive is a negative. Then we put the 2 over 3 to make 2/3 x. And that is telling us to start graphing at 2 on the y-axis, so right there, up 2 from the origin. It comes first this time, but that 2 is still the number that's added or subtracted. In this case, it's positive, so it's added. And then the slope is, again, the number that multiplies the x, the negative 2/3. Remember, the positive or negative always goes with a rise. So we go down 2 over 3 to get our second point. I'm going to do it again. Down 2 over 3. So there we've graphed two equations in two different forms. If this were a longer unit on algebra or a formal algebra class, we would actually, one of our next steps coming up would be to talk about what happened here with two equations crossing like this. It'd be called a system of equations. Now this class, we don't really have the time to get into that, but we did solve problems earlier in the semester that involve a system of equations. We just kind of did a workaround, and I'll show you what I mean by that in just a second. But a system of equations is simply two or more equations, and we're looking for solutions that make them all true at the same time. So here, remember the green, that is the set of all points, all ordered pairs of x and y that make this equation true, in fact, this one. And the blue, that is the set of all equations, points x and y, that make this first equation true. So if it's a system of equations and I'm looking to make them both true, that one point where the two lines cross makes both equations true at the same time. So that point would be the solution to the system of equations. So that looks to be at 6, -2. Now again, in our little 2.5 weeks that we're going to do on algebra in this class, we don't have time to get too far into that, but I wanted to show you that there is that next step where we can have multiple variables, but we have to have multiple equations in order to get a single solution. The example that we did, I'll just show you quick. Earlier in the semester, we talked about mixture problems, and we did problems where we said we need 240 milliliters of 18% solution. We might have asked how much 12% and how much 30% solution should we mix to get that 18%. Well, what we did, we mapped it out as we have 12% and 30%, and we're mixing to get that 18%. We know the only volume we know is that we're going to need 240 milliliters of the 18%. If I let one of these be x, it doesn't really matter which one. I let the 12 be x. The 30 then we said was 240 minus x. And we wrote our equation off of that. So 0.12 times x plus 0.3 times 240 minus x equals 0.18 times 240. And we were able to solve this to get the amount for the 12% and the 30%. Technically, what we were doing there was a workaround to avoid solving a system of equations. What we were really doing there was something like this. 12% and 30% mixing to make 18%. We need 240 milliliters. We could have said the amount of the 12% is x, the amount of the 30% is y, so that 0.12x plus 0.3y equals 0.18 times 240 milliliters. And then on top of that, we would have had a second equation where we know that x plus y has to equal 240. And that then would have been used to solve that system. The second equation here, if I subtract x from both sides, I get that y equals 240 minus x. If I were to put that in here and replace the y, you'll see I get the exact same equation that I created up here. So what we did here is we just kind of skipped some steps to avoid having to write it out as a system of equations. Okay, enough of that. I'll get off that. Like I said, you'll not be tested on systems in this class. I just wanted you to be aware that that tool is there, and we actually have kind of used it. We just worked around it in the way we worded the question. Okay, we also last week we talked about slopes a lot, and that slope being a rise over a run. And if I gave you 2 points, I could use that slope formula. M is our abbreviation for slope, where the rise is the difference in the y-coordinates, and the run is the difference in the x-coordinates. So if I gave you those 2 points, -7, 2, and +1, -4, we could find the slope. I label my points 1 and 2. In my slope, what's the first number up here going to be? Well, y2 is going to be 0.2. The y-coordinate is -4. Minus y1 is going to be 0.1. The y-coordinate is just 2. On bottom, the first number going down here, x2 is going to be 0.2, the x-coordinate, which will be 1, minus x1 is going to be 0.1, the x-coordinate, which will be -7. Now we have to be careful. This minus is always going to be in here because that's part of the formula. Whether this second number is positive or negative, that will be a minus in there. So now let's go ahead and subtract. -4 minus 2 is a -6. 1 minus a -7 is the same as 1 plus a +7, which is 8. A negative divided by a positive is a negative. And both 6 and 8 can divide by 2 to give me 3/4. So it is a -3/4. So we get a -3/4 slope. There are some other formulas that we run into that are very useful. I'm going to focus on the first quadrant for right now, just to make things a little easier on us. So let's say I have a point here at 1, 3, and another one over here at, well, let's say 6. Well, let's do 7, 6. So right here. And remember, we're talking about that line that goes through them. So we're focusing on the part that's between them. But again, that line may extend out in both directions forever. You know, the slope, as we found, was because we could draw in this slope triangle where we had a rise and a run, making this right triangle, where the rise was the difference in the y-coordinates, y1, y2 minus y1. And the run was the difference in the x-coordinates, x2 minus x1. Well, there are other properties of that line that we would like to learn about, or would like to be able to find. One of them is the midpoint, the center, the point that is halfway between those two endpoints. So somewhere in there. And that midpoint, if we trace it up here, the x-coordinate is going to be right in the middle between the x-coordinates. Trace it this way, the y-coordinate is going to be right in the middle between the two y-coordinates. So the midpoint is found by averaging together the coordinates. So the x-coordinate is just the average of the x-coordinates, so x1 plus x2 over 2. And the y-coordinate is the average of the y-coordinates, so y1 plus y2 over 2. So here we have these points 1, 3, and 7, 6. To find their midpoint, we're going to add together the x-coordinates. I have 1 and 7. So 1 plus 7 divided by 2. Well, 1 plus 7 is 8. Divided by 2 is 4. So the x-coordinate of that midpoint is 4. For the y-coordinates, I'm going to average together the y-coordinates. So I've got 3 and 6. So 3 plus 6 divided by 2. 3 plus 6 is 9. So it's 9 divided by 2. 9 divided by 2 is 4 and 1/2, or 4.5. So the y-coordinate of that midpoint is 4.5. So that midpoint is at 4, 4.5. So if I give you like a -3, 7, and 9, 1 is my 2 points. To find the midpoint, again, I'm going to average together the x-coordinates to find the x-coordinates. So for x, I have -3 and 9. I'm going to hold off on that. We're going to do -3 plus 9 divided by 2. -3 plus 9 is 6 divided by 2. 6 divided by 2 is 3. For the y-coordinate, we have 7 and 1. So average them together. 7 plus 1 divided by 2. 7 plus 1 is 8. So it's 8 divided by 2. 8 divided by 2 is 4. So that midpoint is 3, 4. So that's a relatively simple formula to use. Now in some cases, you might be given an end point and one of the midpoint. We're trying to find the other one. So I'm going to put in some notation here for an example, and then we'll work from there. So let's say this is 3, -8. And this one is going to be, let's do -5 and 2. So I'm labeling those point A. Come on. Point A and point B. Those are the end points. So then over here, I'm going to label point M is my midpoint, and that's what I'm being asked to find. So to find the x-coordinate of my midpoint, I'm going to take the x-coordinate of each of the 2 points. So 3 plus a -5 divided by 2. 3 plus -5 is a -2. -2 divided by 2 is -1. So the x-coordinate of my midpoint is -1. For the y-coordinate, I take my y-coordinates here, -8 and 2, and I add them together. So -8 plus 2 divided by 2. -8 plus 2 is -6 divided by 2. -6 divided by 2 is a -3. So the midpoint is -1, -3. So back to what I had mentioned just a minute ago. What if I have one end point and the midpoint? So I give you that I know point A is 7, 1. We don't know what point B is, but we know that the midpoint is -3 and 4. Well, I know that this point here came from taking x1 plus x2 divided by 2. That has to equal 3. Well, if I call this x2 and this y2, x1 is the 7, y1 is the 1. So I know that this negative 3 was found by taking 7 plus x2. So I'm just going to say 7 plus x, since that's the only x that I'm going to be using anymore. Divided by 2 has to equal 3. And now I can solve this to find the x-coordinate of that other endpoint. So to solve this equation, I would multiply by 2, because the whole side is divided by 2, to get 7 plus x equals 6. And then to solve for x here, I have the 7, so I'm going to subtract 7. So 6 minus 7 is negative 1. So x is negative 1. So the x-coordinate of that other endpoint is a negative 1. Now I know the same thing or similar thing is true for the y-coordinate over here. I know that y1 plus y2 divided by 2 has to equal 4. Well, filling in the pieces, y1 is actually 1 plus y2, I'm just going to label as y, divided by 2 has to equal 4. So to solve it, I'm going to multiply by 2. So 1 plus y equals 8. And I'm going to subtract 1. So y equals 7. So the y-coordinate of that other endpoint is 7. Now if I were doing this on a test or a quiz, I would go back and double check. Do I do 7 plus negative 1 is 6 divided by 2 does give me positive 3. So something went wrong there. I see right here, I wrote this wrong. I wrote that as a 3 and it should have been a negative 3. So this here should have been a negative 3. So let's go back and correct that one. So when I went to double check it, I took 7 plus I had a negative 1 here, made 6, would have given me an answer of 3, but my midpoint was negative 3. So I knew something had to be wrong. So let's redo this. We're going to multiply by 2 here. So that's gone. It's still 7 plus x here, but now it's negative 3 times 2 is negative 6. And then we solve by subtracting 7. To get x equals a negative 13. That's quite a bit different than our negative 1 we had. So x here is a negative 13. So now let's double check it. So we've got 7 and negative 13 make negative 6. Divided by 2 does make negative 3. 1 and 7 makes 8. Divided by 2 makes 4. So that endpoint works. So it just goes to show, even I make silly mistakes like that. So it's always a good idea to double check your work when you're done to make sure you can work it backwards. So let's do one more like that. So this time I'm not going to give you point A. We're looking for point A. I'm going to tell you that point B is 2, 7. And the midpoint is 5, 1. So I know this 5 came from averaging together the two x coordinates. So x plus 2 over 2 equals 5. We solve for x. Multiply by 2. So x plus 2 equals 10. And then I'm going to subtract 2. To get x equals 8. So I know the x-coordinate up here of this endpoint is 8. The y-coordinate is found by averaging y plus 7 divided by 2 has to give us that 1. And now we'll solve that. We'll multiply by 2. X plus 7 equals 2. And then, of course, we subtract the 7. X equals 2 minus 7 is a negative 5. So that gives us a y coordinate up here of a negative 5. So again, let's double check this. We have 8 plus 2 is 10, divided by 2 is 5. That works. Negative 5 plus 7 is 2, divided by 2 is 1. So yes, 8, negative 5 works as our solution. Okay, well, back to our points on the graph again. I don't remember what points we had before, but we don't have to have the same ones. We'll go 1, 3, which I think was our starting point before. And let's go, we'll go 9. Yeah, let's not do that. Let's do 5, 6 here, right here. So our line goes through those 2 points. And again, that line could extend on way past them, but all we're concerned about right now is that section between those 2 points. This big piece here. Now we're not finding slope, but I'm going to draw in that triangle that we would use for slope again. Remember, this rise here, that is the rise from our slope, which is y2 minus y1. And the run here, which would be the run from our slope, is x2 minus x1. That's this distance here. And this is a right angle because the vertical and horizontal always intersect each other at a right angle. They're always perpendicular. If I want to know this time the distance between points 1 and 2. So the distance from x1, y1 to x2, y2. If I look at this, well, this is a right triangle, and we can just go back and use a squared plus b squared equals c squared. Only I'm going to rearrange this a little bit. I am going to take the square root here of both sides to get rid of that. So it looks like, and I'm going to put c up front, c is equal to the square root of a squared plus b squared, where c is the distance between those 2 points. Sometimes it's labeled distance, sometimes it's labeled the length of the line segment. It all means the same thing. It's how far our first point is from our second point. So that distance is equal to A is going to be the horizontal distance up here. Remember, A and B are the 2 legs. So A is going to be that horizontal distance. That's x2 minus x1. It's going to be squared. Plus B is this vertical distance, which will be y2 minus y1. And of course, that'll be squared. So to find the length of that segment, the distance between them, now if I drew out the graph like I did here, I could just subtract to get that b is 3 and a is 4. And I could do a squared plus b squared equals c squared off of that. But I want to do this off the points. So I'm using the points 1, 3, and 5, 6. Because we might not always have that graph in front of us to use. And just like before, I'm going to label them points 1 and 2. So my distance is equal to the square root of x2 is going to be 0.2 x coordinate, that's 5, minus x1, 0.1, the x coordinate is 1, that's going to be squared, plus y2, so 0.2, the y coordinate is 5, oops, 0.2, the y-coordinate is 6. So that'll be 6 minus y1. 0.1, the y-coordinate is 3. And that's going to be squared. And now we could work through this. I'm going to work through this one by hand first, and then we'll show that we can actually enter it all in the calculator, and it'll work out just fine. So this distance is going to be the square root of 5 minus 1 is 4. 3 minus 6 is 3. My next step is going to be to square each of those. 4 squared is 16. 3 squared is 9. Adding them together, 16 plus 9 is 25. And now I have to square root. So the square root of 25 is 5. So the distance between them is 5 units. Whatever the units were that we're spacing here on my axes, there's 5 of those units between those points. Now, technically, when we do a square root, there's 2 answers. It would have been 5 or a negative 5. But since we're talking about a distance here, the negative answer doesn't make any sense. Points cannot be a negative distance apart. So the positive 5 is the solution that we want there. So let's pick 2 points here. Let's say I want to go from negative 8, 2 to 4, negative 3. I want to find the distance between those 2 points. So I'm going to use that formula. The distance equals, well, again, it's going to be x2. Call this point 1 and 2. So 0.2, the x-coordinate is 4, minus x1. 0.1, the x-coordinate is negative 8. That's going to be squared. Plus y2. Well, 0.2, y-coordinate is a negative 3, minus y1 is 2. That's going to be squared. Now again, I'm going to work this one out by hand. 4 minus a negative 8 is going to be 4 plus a positive 8. That's 12. Plus negative 3 minus 2 is going to be a negative 5. Now, even though that came out to be a negative, it's not going to matter because we're going to square it in this next step. 12 squared is 144. Negative 5 squared. Now, this is where you be careful on your calculator again. When you square a number, it's always positive. Remember, when you enter your calculator, you must put it in parentheses to get the 25. If you just do negative 5 and squared, it might try to tell you it's negative 25 like that. We know that's not true. So then we go ahead and we add those together. 144 plus 25 is 169. And we take the square root. D is 13. So those points are 13 units apart. Well, back up here. Rather than doing that out by hand, we have the calculator, and I'm sure most of you will use it. So how do we enter this all in your calculator? Well, it depends on how your calculator comes up. My calculator comes up with that square root symbol when I hit the square root button. Some of yours may do that if you have a math type version of like a TI-30. Others just might put the little square root symbol in an open parentheses. If it doesn't do the open parentheses or have this enclosed symbol, you'll have to put a second parentheses in here. So if you just have that little symbol out front, you'd have to have if it doesn't have an open parentheses, you'd have to start out with an open parentheses. And then you put another one. I just put 1 here because I have the symbol. That'd be 4 minus a negative 8. Close my parentheses. That's this part right here, the 4 minus negative 8. X squared plus, in parentheses. Now, some of you, when you do the x squared, you may have to use the arrow to get out of the exponent, out of the power, to get back down. If it puts it, let me go back here and I'll show you what I mean by that. I can force mine to do that. If I did it this way, if I put that power of 2, if I go to put plus in there, you see it stays up in the exponent. You don't want that. So if you get that, if you're up in the exponent like that, you may have to hit the right arrow or down arrow to get out of the power. Plus, and then open parentheses, -3 minus 2, close my parentheses, squared. And then again, if you had just that little square root symbol up front, you'd have to close the parentheses again. Hit enter. And I get 13, which is what we calculated out doing it all by hand. Now, unfortunately, there isn't a good way to do finding another endpoint. Well, there is, but you never get a single solution. Let's say that we have one point here. Point A is at -2, 7. Point B is unknown, but we know that it is 17 units away. To make this work, we have to know one of the coordinates of B. Otherwise, there's just too many possibilities. So, in fact, what it would do is, if we don't know one of the coordinates of B, A is at -2, 7 is right here. 17 units away from that actually forms a circle around that point. There would be any one of that infinite number of points on that circle. So we need more information. So I'm going to tell you that the y coordinate is -1, and I just want to find the x coordinate. So we're dealing with that distance or length formula. We can only find one missing coordinate in an endpoint. So our distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. I try to stay in the habit of writing out the formula before I plug numbers in, just because it helps me from getting things too messed up. So 17 is my distance. I put 17 there. x2, I'm going to say that's the number I'm looking for. That's my x2. So I'm going to put in x there, minus x1 is a -2, plus y2 is my -1 here, minus y1 is 7, that's squared. So now before I try to solve this for a variable, I am going to combine as much as I can. On the right side here, I have -1 minus 7, which is a -8. And then I'm going to square that. -8 squared is a positive 64. Now at this point, there's nothing more I can combine. I could actually FOIL this out and multiply it out, but I don't want to do. I could do x minus a -2 times x minus a -2, but I don't want to do that right now, because that's going to produce an equation that's going to be more difficult for me to solve. So I'm going to leave it like that for now. So I'm solving for x here. If I'm looking at what happened to x, x has had -2 subtracted from it. It's been squared. 64 has been added to it, and then it's been square rooted. So to solve it, we're going to reverse that order. We're going to undo the square root by squaring it. Of course, we square the opposite side as well. 17 squared is 289. Over here, it's just canceled out. The square root symbol is gone. So now we have x minus a -2 squared plus 64. Now I'm going to go ahead and subtract the 64. So 289 minus 64 is 225. Over here it's gone, so I just have x minus a -2 squared. Now the next thing I have to get rid of is the squared, so I'm going to do that by square rooting. So the square root and the squared are gone. I have x minus a -2 here. Square root of 225. Most of us would say 15, but we got to remember there's also negative 15. When we square root, there are two possible answers. And here, both of them do count. So that gives me two possible equations. I have either 15 equals x minus a negative 2, or a negative 15 equals x minus a negative 2. Now to make this a little simpler on myself, I'm going to rewrite this. X minus a negative 2 is x plus 2. I'll do the same over here. X minus a negative 2 is x plus 2. And I will solve by subtracting 2. So 13 equals x is one possible solution. Subtracting 2 over here, negative 17 equals x. So those are my two possible solutions. So this other endpoint is either 13, negative 1, or negative 17, negative 1. Those are my two possibilities. So even given one of the coordinates of that other endpoint is negative 1, we still have two possibilities for the x coordinate. Okay, that's enough of our new material for today. Your homework for today is actually out on Blackboard. If you go to Blackboard for this site, course information, you scroll down. It's a couple of sections up here. You see there's a bunch of worksheets for 419, 421. We didn't get that far, so they're still here. What we're looking at is the bottom one here, worksheet slope, midpoint, and distance. So if you open that one up, it'll look like this. So the first section is using the slope formula. Find the slope between those two coordinates for each of those four. Midpoint formula, find the midpoint of the pair of coordinates for those four. This one, if I give you the midpoint and endpoint, find the other endpoint. This is like we were doing finding point B. And then these 6 are just find the distance between those points using the distance formula. And then a few to brush up. Make sure you're good at that slope-intercept graphing at the very end here. So that's your homework for Wednesday. You guys have a great day. We'll see you on Wednesday.